Hello everyone, my name is Long. Welcome to my project, the Unity Scriptable Render Pipeline Voxel-based Global Illumination, as known as VSGI. It is not the official name for this project and I'm hoping to find a suitable one in the future. The project is originally developed on Unity 2018.2.3 F1 and is used to experiment in different kinds of volumetric effect and global illumination. This is the experimental version, so be advised that anything in this video may subject to change in the future, especially on Unity 2019 since the official API is changed slightly from the experimental counterpart in the Unity 2018. Today, in this video, I will demonstrate how to get started with the VSGI render pipeline using Unity 2018.3.6F1. I'm assuming that you have downloaded the project on Github. The link is in the description. Inside the project, I have the blank scenes created. The VSGI render pipeline can be set up in 4 steps. Step 1 is to create the render pipeline access. Inside the access menu, or right-click inside the access directory inside the project window. Navigate to create rendering VHGI render pipeline access. Then name the file. The access is used to configure the render pipeline. However, in this project, we won't use the asset file to configure the render setting at all. Then navigate to the Edit Project Setting, and in the graphic section, there is a Scriptable Render Pipeline Setting property. In here, you can assign the newly create the render pipeline access. This enables the VSGI render pipeline. Next, in step 2 is camera setup. Click on the camera inside the scenes. Add the new component. This is the VSGI script. The script contains many properties used to configure the VSGI render settings. You must also remember that the camera should be tagged with the main camera tag so that we can preview the VSGI effect in the editor scene view here. Step 3, we will create a few primitives and assign material to them. We won't be able to see the VSGI effect yet until we assign the material using the specific shader to our objects. So first, let's me create a plane and a cube and a sphere, maybe a cylinder. Okay. Next is to create the material. Next name is VSGI. Inside the material inspector on the shader selection, you should select the voxel-based shader basic. The shader reuse the UI from the built-in standard shader, so you should be familiar with this. Currently, only the few properties are supported: albedo, metallic, smoothness, normal map, and emission. After changing a few material property, we can assign the material to an object. Now, we can see that everything is black. It is because the light is not injected into the lighting environment. So, let's get to the step 4, lighting injection. Currently, the render pipeline supports 3 types of light source: directional light, point light, and emissive material. Only one directional light can be assigned to the lighting system. The VHGI script have a sense property where we can assign a directional light. And here you go. The light is injected into the scenes. Next, we have point light. As for point light, we can create a point light inside the scenes, and it will be injected automatically. Let us duplicate another point light. The light here is implemented using the inverse square law, so the range property on the light is not matter at all. Only the intensity will affect how far the light can reach. And lastly, we can use the emissive material to light up the scenes. So I will create a material with emissive property enabled. Now we select the color for the emissive material. I will choose, for example, science, and set the intensity to 1 or 2. Now assign the material to the object. Oh, and remember to change the shader to Voxel-based shader basic. As you can see here, it's spread to a little bit too bright. Let's turn it down a bit. And the emissive surface here is the improvement from the Unity built-in standard shader, where the emissive surface is not accounted in the real-time global illumination. And that zone, it takes to set up the scene with VHGI render pipeline enabled. From here, there are a few more things you can do. The VHGI script has a property skybox that, when assigned, is used to compute the reflection of the skybox. Now let's create another material. I will call it mirror and it have metallic set to 1 and smoothness set to 1. Now assign it to the floor. Oh, and remember, and here we go. Now if we change the sky box, the reflection change as well. The detail, the reflection detail of the object on the mirror is a little bit buggy because this is the voxel representation of the lighting environment. In the future, I'm hoping to implement the screen space ray tracing to simulate the mirror reflection. So this currently the smoothness is best used when you send the value to something lower, perhaps 0.8 or 0.6. Also, the VSGI script contains the resolution property, which determines the resolution of the voxel's lighting environment. The very high setting creates a voxel volume of 256 by 256 by 256, which consumes about half a gigabyte of video memory. I would recommend using high resolution or medium resolution. You can tweak the other property too. For example, the center property, which determines the center of the lighting environment. The lighting environment lie inside the blue bounding box, as you can see inside the editor scenes view. Changing the center will allow you to move the lighting environment to somewhere else, perhaps when the character moving around the scenes and you have the lighting environment follow the character. This is also programmed using the follow camera checkbox, which will follow the camera over here. Also, anything that lies outside the lighting environment will only use direct global illumination. Direct illumination. So remember that anything inside this box will have global illumination that include direct lighting and indirect lighting. Also, the brown property will determine the size of the lighting environment in the workspace. So changing the bound will, for example, we can increase the size of the lighting environment or reduce it. Be aware that these settings might subject to change in the future. So that's all it takes to get the VSGI render pipeline started. If you are interested, you can go to the project GitHub page, the link in the description. And thank you for watching.